Every winter, trillions of snowflakes drift gently from the sky, covering mountains, forests, and cities in a blanket of white. Each one follows an extraordinary journey that begins long before the first crystal appears, not as snow, not even as ice, but as invisible water vapor rising high into the atmosphere. Somewhere inside a cold cloud, that vapor encounters a microscopic particle floating in the air, and one of nature's most beautiful creations begins to take shape. But have you ever wondered how an invisible gas becomes a delicate snowflake? Today, we're following that incredible journey from water vapor to crystal and discovering why every snowfall is a masterpiece of nature. Snow is much more than frozen water. It stores fresh water for spring, protects plants and animals during winter, and reflects sunlight back into space, helping regulate Earth's climate. Yet the process that creates it happens silently, hidden inside clouds thousands of feet above our heads. The story begins with the sun. As sunlight warms oceans, lakes, rivers, and even moist soil, water evaporates into the atmosphere as invisible water vapor. Warm air naturally rises. As it climbs higher, the air expands and cools. Eventually, temperatures inside the cloud become cold enough for ice crystals to begin forming. Floating within these clouds are countless microscopic particles. Some are grains of desert dust carried across continents. Others are tiny bits of sea salt lifted from ocean waves, grains of pollen, or even particles released by volcanic eruptions. Scientists call many of these particles ice nuclei. Under most atmospheric conditions, they provide the surface needed for ice crystals to begin forming. At extremely low temperatures, ice can sometimes form without them, but in most clouds, these tiny particles play a critical role. Around an ice nucleus, water vapor and tiny supercooled water droplets begin gathering. As they freeze, a microscopic ice crystal starts to grow. At the molecular level, water naturally arranges itself into a six-sided structure. This is why snowflakes display their famous six-fold symmetry. The very first crystal is almost unimaginably small, yet it already contains the blueprint for everything that follows. As the crystal drifts through the cloud, more water vapor freezes onto its surface. One molecule joins another, then another, and another. Over time, a single snowflake can contain around 10 quintillion water molecules, each locking into place as the crystal grows. But the crystal doesn't grow evenly. Instead, delicate branches begin extending from each of its 6 corners. These intricate branches are called dendrites. The surrounding atmosphere acts like an invisible sculptor. When temperatures are around minus 15 degrees Celsius and the air contains abundant moisture, broad branching patterns develop into the classic star-shaped snowflakes that appear on greeting cards and holiday decorations. Under different conditions, crystals may grow into simple hexagonal plates. Others become slender columns, needles, or hollow prisms. Every tiny change in temperature or humidity alters the crystal's growth. As a result, every snowflake follows its own unique path through the cloud. Because no two crystals experience exactly the same atmospheric conditions, two natural snowflakes are extraordinarily unlikely to be perfectly identical. Each one preserves a frozen record of the environment through which it traveled. Eventually, the growing ice crystals become large enough to begin their descent toward Earth. Sometimes individual crystals collide and stick together, forming the larger snowflakes we often see falling outside our windows. The journey from cloud to ground may take anywhere from 20 minutes to more than an hour. During that descent, the atmosphere below determines what finally reaches the surface. If most of the air between the cloud and the ground remains below freezing, the crystals survive their journey and land as soft, fluffy snow. If they pass through a deep layer of warm air, they melt into raindrops. And if those raindrops encounter freezing air again before reaching the ground, they can refreeze into sleet. Every winter storm is shaped by this delicate balance of temperature high above our heads. When fresh snow finally settles across the landscape, something remarkable happens. Although it appears solid, newly fallen snow contains a tremendous amount of trapped air. In fact, fresh snow is often about 90% air by volume. Those tiny air pockets act as natural insulation, helping protect plants beneath the snow and allowing many animals to survive harsh winters. They also absorb sound waves. That's why the world often seems quieter after a fresh snowfall, as if nature itself has been wrapped in a blanket of silence. Snow is more than frozen water. It is geometry shaped by physics. It is a record of the atmosphere. It is nature building breathtaking architecture one molecule at a time. So the next time you watch snow drifting gently from the sky, remember what you're really seeing. A journey that began with sunlight warming the oceans, invisible water vapor rising into the atmosphere, microscopic particles floating inside a cloud, a tiny six-sided crystal growing one molecule at a time, and finally a snowflake completing a remarkable voyage through the sky before landing softly on the earth. From something invisible comes something extraordinary, a reminder that some of the most beautiful things in nature are created through processes we can barely see. If you enjoyed exploring the science behind our planet, don't forget to like this video, subscribe to the channel, and join us for more journeys into Earth's greatest mysteries. Thank you for watching, and we'll see you in the next adventure.